Okay, so in this section, we are going to look at the nature of the roots of the quadratic equations. What that means is basically based on the type of the quadratic equation we have, we can have three possible values for x. Actually, that's a weird thing to say because one of those is actually there are no real roots for that one. But I have three examples here that we're going to go through, and I'm going to show you what that means. Okay, so let's go through and plug in the values for the into the quadratic formula. So list A, B, C's, and then you know what to do with the routine. Just go ahead and do that. So when you go ahead and you simplify the radicals, you will end up getting two possible answers. One is 5, the other one is 1. So this quadratic equation actually have two possible answers. Okay, two answers to that. Now another way of looking at the roots of a quadratic equation is that if this was a function, a quadratic function, which you know what that is, that means the graph of this quadratic function goes through the x-axis in two places, and these two are actually, you can call them to be the x-intercepts. Okay, both of them. So this has two x-intercepts. The graph basically goes through these two values. All right, so look at what's happening. We have inside 36 minus 2, that's a positive value, that's 16. The square root of 16, we can deal with that. Okay, let's go to the second example. That should say example B, and then we'll see what happens. Okay, so we have the list of A, B, and C for second example, example B, and plug the numbers into the quadratic formula. That's what you will get, and basically what you will end up getting is the positive 6 plus or minus square root of 36 minus 36 all over 2. In this case, you get 6 plus or minus 0. Square root of 0 is 0 divided by 2. Now, once you have this plus or minus 0, this is irrelevant. That doesn't do anything anymore. It's just 0. All right? So the only answer that you're going to have in this case is one answer. So x1 comma 2 is only 3. That means x1 is equal to 3 and x2 is equal to 3. And it just basically what it means is that you just have one solution or two equal roots. Okay, same thing. So in this case, what it means is that when you graph this function, if this was a function, when you graph it, the parabola, the graph of this quadratic function, only touches the x-axis at x equals to 3. That's your x-intercept. So it has only one x-intercept, only one root. Okay, and what I want you to pay attention to is the value inside of this radical again. Okay, so that value inside the radical, that actually 0, that dictates how many roots you're going to have. In this case, 36 minus 2, the first example we did, this value was positive, we got two different ones. This is now 0, you get one root. And now we're going to go and look at the third option. Okay, in last example, example C, you plug values of A, B, C into the quadratic formula. That's what you will get. Let's polish that. We get x1 comma 2 equals 6 plus or minus square root of 36 minus 48 divided by 2, and we get 6 plus or minus the square root of negative 12 divided by 2, and that's x1 comma 2. All right, now here's the problem. 6 divided by 2, that's okay, but look at the inside of this radical. That's negative 12. From the radical unit, we know that the radicand cannot be negative. If it is, it doesn't have a real root. So this entire thing, so this is undefined. Because of this negative, that makes it an undefined solution. To say the entire thing has no real solution. this. It does have a solution, is based on the complex numbers, but it's beyond the scope of this course. Okay, so look what happens. So no solution when the radical, the value under the radical sign is negative. We have one solution or one root, okay, when the inside of this radical is 0, and we have two solutions, different solutions, when we have the value inside the radical is positive. Now, if you would have graphed this, okay, if you would have graphed this quadratic function, what would have been is that the graph of this function would have been above the x-axis. It will not even cross the x-axis. That's what it means. It doesn't have any x-intercept. So it doesn't have, so there is no x-intercept for this function. Okay, that's what it means. Okay, let's put them all together. Let's do the summary about this nature of the roots. So we know that this is the quadratic formula. Now this value, this expression under the radical sign, the radicand of the quadratic formula, it is called the discriminant. Okay, so this is called the discriminant of the quadratic formula. And based on that discriminant, no, they call it discriminant because it discriminates between different solutions of the quadratic equation. All right, so and this is what happens for each one. Let's write them all up. So if you have, if b squared minus 4ac is greater than 0, the same example as we did, so we do the value and it's positive value, then you will have two distinct or different real roots. Okay, and now you can go ahead and do the rest of it. So if 4ac is equal to 0, what you will have? You will have two equal roots, real roots, or you can say 1, but it's 2 equal, which is the same 1. And then the last piece is that if you have the discriminant 4ac is less than 0, then you will get there are no real roots. Okay, simple as that. I like to show these three possible scenarios on the graph of a quadratic. So in the first case, okay, you could have a graph that looks like this. Okay, any shape that goes through the x-axis in two places, that's part A. That's where this discriminant d, I'm going to call it d, is greater than 0. Okay, and then you have a situation where you have the graph just touches the x-axis. Either the graph is upside up or the graph is upside down, it doesn't matter. In this case, you have a discriminant d that is equal to 0. And then the last case, you have a situation where it doesn't even cross the x-axis. All right, it's upside down, or it could be on this side, but it doesn't ever cross the x-axis, and in this case you have the d that is less than 0. And these are the functional analysis, or actually pictorial representation, of these three possible scenarios for the discriminant. Okay, all right, practice time.